Hello, this is Dan Biggis from IBM. I have responsibility for marketing asset performance management software. And I thank you for your interest and time today in learning more about predictive analytics and how that might enhance your asset performance management strategy. There are really two key concepts that we want to communicate during our time here today. First of all, predictive analytics allows you to take operational information from key assets and develop a predictive model that helps you understand the overall performance of that asset, but more importantly, identify very early on when there might be a potential for asset degradation or potential failure. The overall goal of this is to give you an early warning so that rather than having that asset run to failure or to degrade to the point where significant maintenance is required, the sooner that we can allow you to identify those potential changes and proactively address those so as to minimize the amount of maintenance and unplanned downtime, the better it is for your overall productivity, lower maintenance costs, and improvement of product quality. And in the concept of product quality, we also have a capability there for those organizations that are in production mode, the ability to monitor the overall production process, to make an assessment of the components in the various stages of the production process, and to identify when they might be changing in terms of the drift from the desired mean or such, so that rather than running a full scale or a full set of production and having that end up as scrap, you can identify those minute changes much earlier on in comparison to what you may have done with statistical process control. So we're going to delve into both of these areas in a little bit more detail as we go through this. What makes the capabilities for predictive analytics all the more appealing today is a lot of the changes that have been taking place in technology. So increasingly, those key assets in your organization are instrumented. For those some of organizations that may not have the most recent or highly instrumented assets, microelectronics and miniaturization and lower costs for instrumentation can make it easily applicable to older assets so that you can monitor those in a way that heretofore were seemingly impossible. As a result of that instrumentation, we have assets that are generating a significant amount of operational data. In addition to that, many organizations have quite a good history of maintenance and repair records that can also be used to advise and develop a predictive model. Additionally, we have connectivity today so that whether that's wireless, whether that's wired, whether that's remote, there is so much better capability in our ability to gather that data from each key asset, bring them together, and then use that information to report real-time on the overall performance of that asset. And the key aspect here is the analytical capabilities, taking this historical performance information, the operational information, and building what we call a predictive model that help really identify those particular factors of that asset's performance that correlate with pending the asset degradation or potential failure. And then using those analytic models and applying those to the real-time data feeds that we get from that asset in order to monitor that asset and determine whether or not it's staying within the required ranges, the upper and lower control limits, which we really think determines the optimum performance of that asset, as well as the ability to report on not only an individual asset, but a collection of assets, an entire system, if you will, to get a really holistic sense of how well your assets are performing. What this allows the line of business person then to do is have a user interface that shows them the performance of their assets, historical information, warnings, and details that really allow them to be far more proactive in the way that they look and address their assets, monitor those, and respond in the event that there's certain things. Overall, the benefits at the bottom of the screen, reducing those costs and maintenance concerns, as well as improving things like extending asset lives, improving quality, and optimizing maintenance schedules. And we'll go into much greater detail for each of these as we go through this presentation. What we want to communicate here is that predictive analytics has applicability to so many different industries, especially those industries that are asset intensive, whether it's automotive, heavy manufacturing, energy and utilities, transportation, airlines, in some cases we have mining, as well as electronics and the energies and utility organizations that are pictured in the lower part of this. The message here is to think about your particular organization. What are those key assets? Those are assets that are critical to daily production and productivity. How well do you monitor those? What are your capabilities in terms of predicting the overall performance of that asset with the goal of making sure that asset is as productive and available as possible? The examples that we have here are actually taken and representative of some of the many applications that our customers are using predictive analytics for. What we want to also stress is that the predictive analytics capability in the context of a manufacturing or asset-intensive organization are beneficial to so many different lines of business. It's not just the maintenance and operations organization. As you can see, we've outlined here the way that getting information from a particular asset, whether that is in the plant, in the field, or being used by a customer, getting that information from that asset, doing analysis of that, and providing that back to the line of business can be beneficial to almost 10 different lines of business. From a product design perspective, it may have been designed with one intention and use case or several specific use cases in mind, but as you get that asset or that particular product out in the field, perhaps those customers are using it in a way that was never imagined, that they have implications for warranty, or that may even give you new ideas for how that particular product is being used. That information then can go back to product design for improvements in the next version of that product. For the production and engineering and design organization, especially if they're putting in a new production line, is that process, is that machinery operating as well as planned, or do we need to do minor modifications in order to make that process, and improve the productivity, or modifications to that machine to improve the overall product quality process throughput? For the supply chain procurement organization, one of the concerns there is managing supply and materials inventories. We know that because of some quality processes or the production of scrap, supply chain procurement are always ordering more supplies than absolutely necessary, with the idea that those particular supplies and material inventories act as buffers in the event of production of scrap. The overall goal here would just be to improve the process quality, reduce the amount of supply and materials inventory, and lower the overall production and operations costs. For production and manufacturing organizations, we want to give them a holistic sense as to where are you most likely to have failures across your production line? How can you mitigate those? How can you identify those? And how can you overall improve the uptime and availability of those production assets? For the quality control organization, here it's an issue of quality of materials, quality of the individual processes, production processes that are actually creating those products or those particular components, with the ability to test the overall quality of materials while materials come in, as well as the ability to test the quality of the components as they proceed through the manufacturing process. Clearly, the maintenance organization has a great interest in predictive analytics with the perspective of lowering maintenance costs, improving optimizing maintenance schedules, and as one colleague mentioned, that really trying to make maintenance as boring a process as possible, so that you're not responding to catastrophic failures. You're far more proactive in your maintenance strategies and approaches. At the high level, operations is looking for what are all the overall primary causes of unplanned downtime. How can those be mitigated so that we have continual process throughput, we improve productivity, as well as process quality. When we think about the products that are making their way into the market, again, predictive analytics can advise customer service and warranty. What are the top predictors of warranty claims? Is that an issue of product quality? Is that an issue of usage in a certain geography or a certain type of industry? How can we predict what those warranty claims are, and how can we be far more proactive? In many organizations, the ability to do a thorough assessment of warranty claims can actually lead to improvement in the overall warranty program. Maybe there might be different levels of warranty associated with different levels of use and types of applications of the products actually out in the field. Field service and repair has the same concerns as the maintenance organization, except they're challenged with a very widespread geography to which they have to respond. So their concerns are What are the optimum locations for my spare parts? How do I allocate resources so that when I do have to respond to these field service requests, I'm doing that in the most optimum and cost-effective way possible? For health, safety, and environment, the overall theme there is risk. Risk of avoiding catastrophic failures that could lead to injuries, or the issues of product quality that could lead to recalls or an inordinate amount of customer claims against those particular products. And lastly, for the data scientist or the statistician, the aspect there is the accuracy and the capability of the underlying models. What tools are in place? What current capabilities do you have to have sophisticated analytical capabilities to assess asset performance and model that accordingly? Another way to look at this from the various lines of business and the particular benefits is to make the case that multiple lines of business have common interests. It's not just a single line of business who benefits from a lower unplanned downtime. When you look across this, and certainly you can map this to your own organization, the case here is that benefits accrued by predictive analytics, the ability to be far more proactive, benefit multiple lines of business. Hopefully this will help you make the case to consider predictive analytics in the context of your organization, the overall asset performance management strategy, so that it's not just making a case for one single organization or one single department, but realizing that there are benefits across the entire organization. What we want to do now is go into put greater detail regarding the overall approach to predictive analytics in the organization. We've broken it into three areas: the model process, the monitoring process, and the actual acting upon data and information that you get real-time from assets. We begin with the model process. Those gears represent a critical asset in your organization. We can look at maintenance logs, repair invoices, and actually do an analysis of that information to determine what were the most likely problems with a particular asset. When was what were maintenance was applied to that asset? What were the particular repairs? What were the times and dates of those repairs? And via an analysis of that, we can actually help optimize the overall maintenance schedule. We can complement that with historical information, operational data from those assets, and that's represented by the various icons. There's this time, temperature, weather, humidity, vibration, etc. And via a combination of both the unstructured and structured information regarding that asset performance, we can do an analysis of what particular data factors, what data sets, what information there really helps to describe the performance of that particular asset. And then from that, build a specific model that describes the overall, essentially, if you will, a PF curve for that asset that predict potential degradation very early on, so you have a much better understanding and ability to proactively address potential asset failure or degradation. And then we go one step further. Based upon our analysis, we're actually able to make some recommendations as to, for a particular failure mode, what's the most likely probability of cause, or in a particular case, what is the best process or procedure to take place. So we try to take a very holistic approach to this, understanding what are those factors that actually and accurately describe the particular asset process, and then how do we take that all the way to modeling that, and then making recommendations as to, under specific alerts, what is the best action to be taken. Once we've developed that model, we then apply that in the real-life, day-to-day, real-time aspect. So we're taking that model and comparing that against real-time data that we're getting from that particular asset. In the event that there's an alert, then we can initiate an action, whether that's a work order with recommended actions, whether it's modification of a production schedule, working with an operator to review procedures, or even going back and modifying the process. The overall idea here with that monitoring asset performance in real time is to, as early as possible, detect any potential problems with asset degradation or potential failure. For those organizations operating in a field service mode, that might be acting to initiate a service call or optimize the overall parts and inventory locations over time as we get more and more data with respect to the particular assets and their operations. The other aspect of this is looking at this real-time data associated with materials, components, parts, as well as the production processes, and in this case, monitoring for quality, making sure that particular machine is working within that calibration, or as the components move from one step of the assembly process to the next, they are all within the specified requirements that we indicate. In the event there's a drift in product quality because of the quality of the components or substandard, or the deterioration or modification or movement in the calibration of the machine, then we can initiate alerts and then conduct some analysis as to what the particular problem is. The overall goal with product quality is to make sure that to the greatest degree we're identifying potential problems well before they really lead to making a significant amount of scrap or significantly producing or reducing the production yield. Let's take these concepts a little bit more in depth. So for any particular asset, you might have many different sources of performance data, whether that's time, temperature, electric resistance, vibration, lab tests that you might have done, as well as unstructured information associated with maintenance systems, such as repair invoices, warranty claims, test results. And our goal here is to look at all of this relevant information and really to kind of give an assessment as to which of this is relevant, how do we build these specific asset models, and then we ask these questions: which of these data best predict the performance of that asset? How can we identify the main factors for failure? When is that asset most likely to fail? Based upon our historical maintenance information, what's the optimum maintenance schedule that I'm only producing or I'm only executing maintenance when it's absolutely necessary? And when I do that maintenance, what are the most effective and lasting repair procedures? For those organizations that are in the manufacturing production process, what are those variables that affect my process quality? How can I better control them and keep those within the specified requirements? And lastly, maybe some advice on, based upon warranty assessments and such, should we modify the warranty program? And the overall concept here is taking all of the relevant information associated with that particular asset, both structured and unstructured, applying a model to gain the insights that benefit the various different lines of business and help us to improve the quality of the asset, the quality of the production process, or things like even our warranty program. We'll dive a little bit more deeply here into this development of a model. So we begin again with the various data sources, both structured and unstructured. And here we have out-of-the-box algorithms so that we can do an assessment of just historical maintenance records to help identify the optimum maintenance schedule and procedures that we can do. Or we can look exclusively at the sensor data that we get from that asset and develop a health score for that, so that as we're comparing that particular asset's operations in real time, we can determine whether or not that asset has potential for failure or there's certain degradation based upon calibration of that particular asset. We can assess the top failure reasons for an asset and provide a probability around each of those. Or we can combine things like maintenance and sensor health model to develop an integrated health model perhaps to achieve a greater degree of accuracy in predicting that particular asset performance. Also give clients the capability to develop custom models as well as providing industry-specific models, asset models right out of the box. As a result of applying these algorithms, what you typically find is that out of all the potential sources of data, there's really only a subset of operational data that best describe that particular asset performance or predict that asset's failure. So the overall capabilities of our analytics helps you take a potentially large set of data, look at the correlation amongst those key data factors, and develop a very accurate predictive model. And we have a significant, quite a number of statistical algorithms and capabilities to help make that process as straightforward and as simple as possible. Let's apply these concepts to the various lines of business. We'll have a couple examples as we go through here. First of all, the maintenance manager. We've broken this up into the areas of what focus is, what the particular process is, and what capabilities will really benefit that particular line of business. So for the maintenance manager, they're concerned with the maintenance schedules, parts availability, the technical skills, the procedures that would need to be executed, the overall efficiency of executing those procedures. In this particular process, we're going back to that model of process that we mentioned earlier, where the gears represent the critical assets, We're getting information, both historical information, unstructured and structured, and using that information to develop the analytical model. That analytical model can reveal to us the most frequent failures. We can develop an asset health score to assess the overall performance of that asset. We can conduct root cause analysis and even do what-if scenarios, so that in the case of a particular asset failure or degradation, what's the best approach to take? Should we take the most cost-effective approach? Should we take the most timely approach? Or a particular strategy or approach that might reduce overall risk? So you have lots of capabilities in terms of doing this analysis and then taking the results of the analysis and applying that to how you might actually mitigate that particular asset problem. We then take that model and apply that to the real-time data that we're getting from that asset, and in the event of a deviation or an alert or a warning, we can issue a recommendation and automatically initiate a work order. We are tightly integrated with IBM Maximo products for organizations that have already invested in IBM Maximo. There's a very close integration and the ability to use predictive analytics in the event of an alert, automatically initiate a work order with recommended actions for that maintenance organization to take. And at the bottom of the screen, some of the benefits that are accrued as a result of applying predictive analytics and the benefits realized by the maintenance organization. For maintenance, we want to jump back to the quality aspect, what we call a quality early warning system, or QEWS. A lot of organizations are already using statistical process control to do an assessment of their overall operational quality or product quality. And it certainly has been extremely valuable in terms of quality improvement over the last couple of decades. What IBM has done has made significant research and intellectual property investments in taking those SPC capabilities and extending those and significantly enhancing them. The actual benefit here is that in comparison to SPC alert, IBM's quality early warning system has actually enabled organizations to identify quality issues significantly earlier. In this particular case, it's actually 6 weeks earlier in this particular process in comparison to an SPC analysis of that quality process. So if we think about the quality early warning system and applying that to the production line manager, they're concerned about quality in 3 different areas: quality of the raw materials, quality of the actual production process, and quality of the final product. And again, here we've outlined it in the capabilities of, in the 3 categories of focus, process, and capability. The production line manager is concerned with the quality of the raw materials coming into that process. Do they meet the required specifications? Are they substandard? If so, how do we identify that with our quality analytics and eliminate those from actually entering the process? As we go through the production process, again, we're applying the quality analytics capabilities not only to the components as they go from one step of the production process to the next, but also to the actual machinery and the calibration and settings of the machine to make sure they're operating within the desired range. And then finally, the application of the quality analytics at the very end to make sure that that process, or I'm sorry, that product meets the quality specifications that we require. Another aspect or application of predictive analytics, very similar to the maintenance organization, but this time associated with the field asset. Here they've got the responsibility for addressing maintenance concerns over assets that might be widely and geographically distributed. And here, again, same process, looking at the key assets, developing the predictive model for that asset so that we can anticipate what the most frequent failures would be, develop an asset health score, root cause analysis, and then once that asset is in operation, getting real-time data for that, comparing that against our asset model, and in the event of an alert, issuing a recommendation and work order so that we can proactively address that particular asset problem in the field. Again, the overall benefit of predictive analytics is to identify that potential problem as early as possible. And for many service organizations, they're using this capability to really redefine what they're doing. It's no longer are you leasing a particular asset, but you are leasing or you are renting or you're purchasing the capability. And these organizations have moved far more from a sales and leasing mode to really provision of a particular service or capability. Here's what a UI might look like for someone involved in making. In this particular example, we have a pencil with a graphic. We have a left-hand corner indicating the key areas that we're concerned with. We also have real-time indicators of the various measurements that we're getting from the main engine. We have a dependency graph showing the interrelationships of all the various critical assets on board this vessel. You can see by the sensor values and anomaly scores, there's actually three measurements: exhaust temperature, intake air pressure, and lubed oil P2 temperature that are signaling that there's an alert. Based upon this real-time analysis, we've developed the recommended, error parts list, what might be the most likely problem here, and it's recommending or indicating that lube purifier unit. And then we also have recommendations checkpoint for selected parts. What should you actually check? What's the best thing to investigate, as well as a visual for where that part is located on the actual engine, and details for the maintenance organization so that they can get the accurate information, technical documentation, policies, and procedures associated with that particular asset, so they can affect very proactively affect the maintenance to that asset. We realize that in order to make an investment in predictive analytics, there needs to be an economic argument. What we've done is we've worked with Nucleus Research, who's renowned for its development of ROI models. And based upon their analysis, these are some of the economic benefits that can be realized by an organization that defines predictive capability with asset management strategy. As you're looking at this, think about how these particular benefits, the percentage improvements, would benefit your organization, both in reduction of time and reduction of costs. For those of you who are interested in this, IBM is happy to work with you, getting some performance and financial data, and actually apply this Nucleus Research model to estimate potential economic benefits for your organization. And lastly, I will leave you with a few questions, a few rhetorical questions, if you will, kind of assess where you are with respect to your ability to employ predictive analytics. First question is, to what extent are your critical assets currently instrumented? If you're already fully instrumented, you're in a very good position to get this data from real-time predictive models and monitor that in real time. Next question is, what type of operational data can you obtain from these critical assets? What's the quality of that data? Which of those operational data would accurately describe the performance of the critical assets? Do you have the capability to capture and manage large volumes as we are entering the Internet of Things era, the ability for assets to create a large volume of real-time and operational data sometimes is a challenge in managing those anticipated large volumes. If you're currently doing some analysis of your operations, what analytical tools are you currently employing? How sophisticated are the algorithms and the statistics? And could there be better capabilities to help you model those particular assets and improve your understanding of the asset performance? And then do you provide real-time operational data to the various lines of business to help them understand the current operations of those key assets and alert them to any pending failures? And then lastly, what additional lines of business would also benefit? We mentioned earlier in this presentation that not only is it the maintenance operation organizations, but so many different other lines of business can benefit from applying predictive analytics to key assets within their organization, whether that's in the shop, whether that's in the field, whether that's in products that they manufacture. So think holistically in terms of the benefits of predictive analytics, applying that to key critical assets, and the benefits to be obtained via that. And then finally, 2 links to some of our capabilities with respect to asset performance management. If you're interested in this, I ask you to investigate these links and to learn much more detail. Finally, I thank you for your interest today and your willingness to spend some time with us, and I hope this has been educational, beneficial for you, and perhaps even motivational to consider the application of predictive analytics in your asset performance management strategy. Thanks very much.